Welcome to the RiverMorph webcast. Today we're going to go over RiverMorph tools. And if you're not familiar with RiverMorph, it is a stream assessment and natural channel design software tool. We like to think that it has everything that you need to do stream restoration analysis and natural channel design right at your fingertips. And if you want to find out more information about RiverMorph, you can visit us online at www.rivermorph.com or call us at 866-748-6673. So to start out, you're going to want to load up a database, and you can either create a new database or load up the existing one, which is what I've done here. And then the tools that we're going to go over today are regime equations, resistance equations, TR55, peak flow, sediment transport competency, Shields entrainment function, regional curves, GIS, and the gauge analysis. We will not go over Flowset PowerSed. That's a sediment transport capacity module, and we'll do that under a separate webcast. And then just pointing out that on your system of measurements, you can either use English units or metric units. So the way these tools are basically set up, they're pop-up tools, so you can be working in the classification form, for instance, and then use these tools. And so it's really set up so you can be working in the software, and if there's some additional information you may need, you don't have to go out of a module to get to those tools. So this first one we're going to go through is regime equations. Regime equations were developed by Williams, and Williams used both natural rivers as well as artificially or man-influenced rivers, and both stable rivers and unstable rivers. So you really wouldn't want to use Williams equations excuse me, for natural channel design, but nevertheless they give you some decent information. So for instance, if I want to know belt width as a function of bankful width. So let's say if I knew I had a 30-foot wide bankful stream, that would say I would need a belt width of about 160. You can also look at meander wavelength, just pretty much drop and drag, and that'll set up the equation for you. And then you can type in a value and it'll make a determination for you. So that's pretty much how regime equations work. In resistance equations, this is just a velocity discharge calculator. You can use Manning's, Chezy, Darcy-Weisbach, U-Star, or Pipes. In the case of Manning's, different ways that you can get Manning's in, Lamarinos, Cohen, stream type, Jared's equation, or if you know in. So for instance, let's say this is a C4 stream type, which it is based on classification. See our cross-sectional area is roughly 21.23. Wetted, should I get that? Okay, our wetted perimeter is basically, don't have that in front of me, so I'm just going to assume a value. And then hydraulic slope would be 0.00445. So this would be, would get us a velocity discharge based on, quite a bit higher than what we have over here. But again, this is based on a wetted perimeter, also stream type in. So we may, if you want to do Lamarinos, this would require a hydraulic radius, which we'll just say is about 1.3, and then D84, which I'm just going to guess and say 85. So now we would have some different values coming in as well. And now one thing I'll point out too, when I was on stream type, I had that for medium to large rivers. I probably want to do that for small river with vegetation influence, which then gets it into more reasonable value based on what we had over here. Okay, so Chezy's works the same way, just need to enter in Chezy's roughness coefficient. Darcy-Weisbach works very similar, just need to calculate a friction factor, and you type in what's in yellow and what's in blue is calculated for you. You can use Leopold, Woolman, Miller, or you can use Hay. You over U-Star, again, works similar way. This Culver calculator is, you can basically use these sliders to set the roughness, or you could type those values in if you wanted to. I'm just going to assume some values here, and then you can calculate a full flow capacity as well as a full flow diameter for that. So in this case, we're slightly undersized. Okay, so that's resistance equation calculator. TR55, this is basically NRCS methodology. Again, you would type in a drainage area, and you can be acres or square miles. Rainfall, which I'll say 6 inches. Different rainfall distributions, we'll use type 2. In this case, go with about 75, and then time of concentration, and from that you'll get a runoff volume and a peak discharge. So again, just TR55 methodology. Okay, the Shields entrainment function, basically what this does, shows you the Shields curve plus Roskin provisional data, and then you can hover your mouse to just help you read the curve, which is going to give you the values up here. But anyway, this is basically just showing you the curves that are commonly used. Okay, this next tool, which is regional curves, is a little bit more complex. What regional curves does, first of all, you have to load up a regional curve database. You could create a new database or load up an existing one. I'll go ahead and load up an existing one. And you could use RiverMorph to set the regional curve, and I would just create a new curve, which I already did down here under test. And then I could then use this function to just select different values. In this particular data set, I don't have enough to really set up a regional curve, but it automatically loads the data. So if you're collecting data and with the intent of developing regional curves, you can then create the regional curve within RiverMorph. And then if you want to view regional curves, you can basically look at drainage area as a function of discharge area, width, and depth, and all your regional curves are listed here. So you could create plots of different regional curves. So I'm going to do area, and I'm going to do North Carolina Mountain Piedmont, do Maryland Piedmont, I'm going to do Eastern USA, I'm going to do the Upper Salmon. Hit OK. So it's going to be, let me resize this a little bit so it's going to bounce around a little bit on your screen. Okay, so if I select the curve down here, now I've got North Carolina, Maryland, Mountain Piedmont. Let's say if I enter in 50 drainage areas, so that's saying my area should be about 293. If I go with Maryland Piedmont, it'd be 305. Go with Eastern USA, be 298, and then used Upper Salmon all the way in Idaho, be quite a bit different. It'd be 71. So key is you need to have a regional curve for your area. Make sure you're using the right regional curve. And then the way this is you just plot the regional curve or curves that you want to look at, enter in the value down here, and it will give you the, in this case, the area. And again, you can set these regional curves up for discharge, area, width, or mean depth is the ones that you would typically use. So that's how the regional curve module works. And then, I'll probably save that. And then the GIS module. So this is basically this is not really GIS operating within RiverMorph. It is just a mapping tool that we built in RiverMorph that allows you to get some basic information out. So first thing you want to do, just like GIS, you're going to want to load a theme. In this case, I'm going to load up an image. So this is an aerial photograph. So I'll select it to put it out there. And then, so these are common tools that you're used to seeing if you're a GIS user. What we've customized is these measurement tools that allow you to measure linear wavelength, belt width, radius of curvature, stream meander length, and arc length, as well as sinuosity. So one of the first things that you probably want to do is when you load up if you're loading up an image like this, you want to check the scale. So what this does is it allows you to measure something of known value, which I measured an inch here, and this is a scale of 1 inch to 440. So this is digitally ortho-rectified. In other words, the scale is already embedded in here. So I'm going to go ahead and just type that 440 in. So let's say if it wasn't, and that measured 200, and I knew it was supposed to be 440, if I just key in the right value for what I just measured, then it's going to scale everything by that factor as you move forward. So the way that this would work is, let's say if I wanted to measure radius of curvature, I would just select the radius of curvature button, and then I would pull out. So I'm measuring a series of radiuses here. Go ahead and get this one over here. if I was doing this, I probably want to zoom in a little bit. And then I can get my average, mean, max. If I want to do sinuosity, if I have a, I could select, if this was a, ArcView file, I could just select that digitized line and use this K, or if I want to measure by digitizing K, then I would just come in here and do a series of clicks. Again, if I was doing this for real, I'd probably be zoomed in and doing this, spending a little bit more time on how I map this out. And then when I'm done, I'll do double click, and then it'll give me that sinuosity out there. So I can do this for, again, stream meander wavelength, belt width, and linear wavelength. And then if I want to use this to load up dimensionless ratios, when I close out of here and say no, if I had said yes, then when I went to close out, it would give me an option to load particular values up. And if I chose to do that, the data would have been loaded here in pattern. So that'd be the the minimum, maximum, and average value, for instance, for radius curvature. Okay. So that's how that tool works. Gauge analysis. So this takes a while to load up if you have a lot of gauge data stored in here. But basically what this does is it allows you to load up a series of gauges, and then you can go out to USGS's website and get more gauge data if you choose to want to do that. And so, one of the ways that you can, so this would be the gauge tool. And so we can download annual peak flow data, mean daily flow data, measurement data, increment of flow data if you have continuous flow data. But the way that would typically work is you would load up you would add a new gauge, and you would type in the name of that gauge, which I won't bother to do here, and then you can select an existing gauge if you want to just go with an existing gauge, which I'm going to do in this case. And it's taking a little bit of time here to load all that up. So it's loading that gauge data up. And what we can do within this, we can go out to USGS's website and we can download gauge data if you have that particular gauge number. You can also go out to, you can look up a gauge if you don't have that gauge number as well. So now we're looking at this particular stream, and we can either, so if the gauge number, if we know the gauge number, we're going to type it in. If we don't know the gauge number, we could look it up. And the way that we would look it up is we would hit this lookup tool, and then we would go to, we would select state, we hit submit, then we would select North Carolina, hit submit, and it would be loading up all the gauges, and then I could type in name of the river, hit search on page, and it would make this a little bit bigger here. And then it would basically go through on the page and then find that particular one going through. So once you find that particular site number or gauge number, you could then go through and then key that value over into RiverMorph. Okay, so then you would hit download data from USGS. So now it's going to go out to USGS's website, and it's getting both the peaks and the mean dailies as well as the measurement data out there. and then you'd hit extract all, and now it's going to go out there and it's going to download the different peak flow data, mean daily data, as well as the measurement data. So then I'm going to close this out. So if I go over to annual peak data, all that data is going to be sorted, and I can see that for a discharge of, about 1.5 year recurrence interval would be 12.266. Now, if you knew the discharge based on the curve, because you went out and you measured it, or based on the actual field conditions out there, you would list the discharge and you could type it in and then hit return, and it would automatically calculate the return interval for you. Or if you had a particular return interval that you wanted to see what the discharge was that corresponded with it, you could then get the discharge. So then mean daily flow data, this is basically based on mean daily data, and so we ultimately often will use mean daily flow data to come up with the flow duration curve. One thing I'll point out is when you're downloading the data, especially if it's mean daily flow data, if you see any blank spaces, we're kind of at the mercy of USGS's website and the data that they have there. So if you go out there and you see any blank spaces, it's good to go ahead and just delete those rows. And this particular value is probably an errant value because this is a very big stream. So that would be how the mean daily flow data would work. Then the measurements tab is how you're basically looking at the different hydraulic geometry data. So you can compute the power functions, and then you can also see the plots. In this case, this would be width versus discharge for that particular stream. And that would be all the different data sets in there. So, so that's basically how the gauge data works. So that's basically it for this webcast. I want to thank you for sitting in on the RiverMorph webcast today on going over RiverMorph tools. If you need more information on RiverMorph, please visit us online at www.rivermorph.com or call us at 866-748-6673. Thank you,